Video we are going to discuss about electrophoresis. Now you have heard this term electrophoresis a lots of time. Now it is made up of two words. You can say electro refers to the energy of electricity in Greek, whereas this phoros means carry across. Okay, so that is how the electrophoresis is made up, okay, of these two names. Now this electrophoresis is a technique, okay, by which you separate or resolve charged molecules from a mixture under the influence of applied electric field. Okay, now those charged molecules which you can separate with the help of electrophoresis can be a nucleic acid, amino acid, peptide, protein, or nucleotides. Okay, these all are the charged molecules which are separated or resolved from a mixture with the help of electrophoresis under the influence of applied electric field. Now, under the electric field, the charged molecules will move or they will migrate with a particular speed, and that speed of the charged molecules depends upon their charge to mass ratio. Okay, so the speed with which the charged molecules move, the charged molecules migrate under the influence of electricity, that speed depends upon the charge to mass ratio of these charged molecules. Now, according to the laws of electrostatics, consider an ion which has charge Q. Now, in the electric field of strength E, that ion will experience an electric force Fe electrical. Okay, so yeah, F electrical is equal to Q into E. That is, a charged molecule, an ion with charge Q under the electric field of strength E is experiencing an electric force of F. Okay, F is equal to Q into E. Now the resulting migration because of this force of the charged molecules in the solution is opposed by a frictional force. Okay, so this frictional force which is opposing the migration of these charged molecules in solution is given by F frictional is equal to V into F. Now this V is representing the rate of migration of charged molecules, and this F is representing the frictional coefficient. So the frictional force that is opposing the flow of charged molecules is equal to rate of migration into the frictional coefficient. Now this frictional coefficient depends upon the size and shape of the migrating molecules and viscosity of the medium. Okay, so on the base, the frictional coefficient depends on two things: the size and shape of the migrating molecule and the viscosity medium. Now in a constant electric field, the forces on the charged molecules balances each other. Okay, so the electric force is equal to frictional force, and that is why Q into E is equal to V into F. Okay, that is the charge on the ion into the strength of electric field is equal to the velocity of the molecule multiplied by the frictional coefficient. Now each charged molecule moves at a constant characteristic velocity. Now the migration of this charged molecule under the influence of an electric field is expressed by this electrophoretic mobility mu. Now this electrophoretic mobility is the ratio of migration rate of ions to the applied electric field. Okay, so the migration of the charged molecules in the electric field is expressed in terms of electrophoretic mobility. So if you rearrange the equation a little bit, then mu is equal to V by E, which is equal to Q by F. So according to this equation, if two molecules are having same mass and same shape, then the molecule which has a greater net charge, that molecule will move faster towards the electrode. Okay, so this is what is represented from this equation. Consider two molecules, they have same mass, same shape. Now which one of them will move towards the electrode at a greater rate? Well, the molecule which is having a greater net charge, that will move faster towards the electrode, and that is represented by this equation. Now, electrophoresis are of two types. First type is moving boundary electrophoresis, and the second one is zone electrophoresis. Okay, moving boundary electrophoresis and zone electrophoresis are the two types of electrophoresis. Now, this moving bound electrophoresis, which you also called free boundary electrophoresis, okay, both are the same terms. It is the electrophoresis which is carried out in a free solution. Okay, so the electrophoresis which is taking place in a free solution, electrophoresis in free solution, that is your moving boundary or free boundary electrophoresis. And this type of electrophoresis was developed by Tiselius in 1937. Now, to separate different charged molecules in a mixture, okay, in this technique what is happening, we are trying to separate different charged molecules in a mixture. And how do we do that? Well, we put that mixture of different charged molecules in a sample, as a sample in a glass tube, and that glass tube is connected to electrodes. Okay, so the sample containing the different charged molecules, the sample containing the mixture of different charged molecules is put into a glass tube, and that glass tube is connected to electrodes, and that is how you are doing the moving boundary electrophoresis. Now, the sample which we are putting in the glass tube, what is that sample? Well, you dissolve this mixture of different charged molecules into a buffer solution. Okay, that is your sample. Okay, dissolved molecules in a buffer solution, and this buffer solution has two important role to play. Okay, it acts as an electrolyte, as well as it maintains the desired pH. So you take your molecules that you want to separate, you put it into a buffer solution, you make a sample, you put it in a glass tube, and then you connect electrodes, and that is how you are doing the moving boundary electrophoresis. So in this system, the electric potential is applied across the tube, and because of this electric potential, obviously the charged molecules will migrate toward electrode. Now the thing is that different charged molecules will migrate at different rates. And because of this, because of the fact that the different charged molecules are migrating at different rates, a number of interfaces and boundaries are formed between the leading edge of charged molecules and the remaining mixture. Okay, because different charged molecules are migrating at different rates, number of interfaces and boundaries are formed between the leading edge of charged molecules and the remaining mixture, and that is the reason why this type of chromatography is known as moving boundary electrophoresis. Now, this electrophoresis technique that we just talked about, the moving boundary electrophoresis, this technique is applied for the analysis of a mixture. Okay, if you want to analyze some sample, then you use this technique. This technique is not used for fractionation of a complex mixture. It is used for analysis, but not for fractionation. Now, the other type of the chromatography which we just named is the zone electrophoresis. Now, in zone electrophoresis, what happens is the sample is constrained to move through a solid support, such as a filter paper or a gel. Okay, the sample is constrained to move through a solid support. And that solid support, if that solid support is your filter paper, then that is known as paper chromatography. And if that solid support is gel, then that is known as gel electrophoresis. So gel electrophoresis is a type of zone electrophoresis. And this technique, this zone electrophoresis, is used for both analytical purposes as well as the preparative purposes. So that is what the introduction to the electrophoresis is all about. Thanks for watching. See you next time.